How can we protect humans on Mars from dangerous solar storm radiation? The video discusses the significant challenge of protecting astronauts from dangerous solar storm radiation on Mars, highlighting various strategies and ongoing research aimed at mitigating this threat. The radiation hazard on Mars. Mars poses a unique radiation threat to astronauts due to its lack of a protective magnetosphere and a thin atmosphere that is only about 1% as dense as Earth's. This environment allows high-energy radiation, such as protons, ions, neutrons, and gamma rays, to penetrate the Martian surface. Additionally, intense bursts of radiation from the Sun, known as solar energetic particles, SEPs, can pose severe risks to human missions. Addressing space weather risks. NASA and the National Oceanic and Atmospheric Administration, NOAA, are actively developing strategies to manage the radiation risks for astronauts both in transit to Mars and while on its surface. Given the communication delays between Earth and Mars, it is crucial for astronauts to independently assess space weather conditions locally. Gina DiBraccio, acting director of the Planetary Science Division at NASA, notes that scientists are utilizing observations and models to create tools that can provide advanced warnings of potential space weather threats. Recent solar storm event. The urgency of addressing radiation hazards on Mars was underscored by a major solar flare in May 2024, which sent X-rays, gamma rays, and charged particles to Mars within minutes. Analysts at NASA's Moon to Mars (M2M) Space Weather Analysis Office monitored this event closely, providing real-time space weather assessments. NASA's MAVEN, Mars Atmosphere and Volatile Evolution, spacecraft was instrumental in observing the Sun's activity and its effects on the thin Martian atmosphere. Upcoming missions to enhance monitoring capabilities to improve Mars space weather monitoring. The MAVEN spacecraft will soon be joined by two new orbiters, the Escape and Plasma Acceleration and Dynamics Explorers, ESCAPADE, managed by the University of California, Berkeley's Space Science Laboratory and NASA. These spacecraft, launched aboard Blue Origin's New Glenn rocket, will significantly enhance the ability to monitor and study incoming radiation on Mars. Radiation measurements on Mars. The recent solar storm led to the largest surge in radiation levels ever recorded by NASA's Curiosity rover's Radiation Assessment Detector, RAD, on Mars. The Martian surface radiation environment primarily consists of galactic cosmic radiation, GCR, and secondary particles generated through interactions with the atmosphere or soil. SEPs from solar storms can dominate the surface radiation levels for hours to days. According to Don Hassler, principal investigator for the RAD, protecting future human explorers from this radiation remains a significant challenge. Data gaps and future needs. There are considerable gaps in the ability to predict space weather on Mars in real time, largely due to limited observational data, such as the lack of monitoring from the Sun-Mars Lagrange Point 1 and the far side of the Sun. James Favors, NASA's Space Weather Director, emphasizes the need for an Earth-independent space weather capability to address communication and prediction challenges. This capability would involve developing a space weather infrastructure integrated into the crew vehicle, allowing the generation of actionable predictions without relying on Earth-based data. Conclusion. Protecting humans from radiation on Mars is a complex problem requiring advanced technology, independent space weather prediction capabilities, and enhanced observational tools. Future missions and new spacecraft like ESCAPADE will play a vital role in providing critical data to safeguard astronauts on their journey to and stay on the Red Planet.